Okay, in this example I'm going to start with an equation. In this case, x minus 2 squared is equal to 2 times the quantity y plus 5. And notice I put that right underneath the standard form so that we can pick out some things, and then we'll graph it and label a whole bunch of other things. So first thing I hope you see is that the vertex is going to be at hk, so that's going to be 2 for the x coordinate, and if I have this as minus negative 5, then k would be negative 5. So it's always going to be the opposite of what's in there. So I have the vertex. I see that 4p is equal to 2. Actually, I want to change this because I want things to be a little bit different. So I'm going to make that negative 2. So if I said that 4p is equal to negative 2, p is going to be equal to negative 1/2. And we'll see where that's going to come in. So if I wanted to graph this, I have a vertex at 2, negative 5. Okay? Because the x is being squared, I know it either opens up or down. That is why I wanted to make this negative. If this thing is negative, it's going to open down. If it was positive, it would open up. Okay? Same thing over here. If p is positive, it opens to the right. If it's negative, it's going to open to the left. So in this case, since p is negative, I know it's going to open down. And I know that the focus is going to be negative 1/2 away, or 1/2 away from the vertex. So since I know it's opening down, so a lot of times I would say it opens down. The next thing I would try to find is the focus. And since I know the coordinate that's changing is the y coordinate because it's going down 1/2, I could say that it's at 2 and either negative 5.5 or 5.5 or 11/2, whatever you want to do, however you want to represent it is fine with me. I forgot the other thing I usually like to say is what's the axis of symmetry? And it's always going to be whichever variable is being the squared. So in this case it's x squared, and it's going to be x equal to whatever the x coordinate of the vertex is. So, and it's also the x coordinate of the focus. So it's going to be x equals 2. So I have this axis of symmetry. Well, right away that should tell you that our directrix is going to be perpendicular to that. So that's going to be y equals, but y equals what? Well, if I moved half for my focal length, or p, to get down for the focus, I would move from the vertex in the other direction to get the directrix. So if I was at negative 5 and I wanted to move 1/2 in the other direction, I would say it's negative 4.5. So I'd have a directrix that looks something like that. Okay? If I wanted to find out what my focal width was, the focal width is always going to be the absolute value of 4p. So it's always a positive value. So the 4p was here at negative 2. That's going to be equal to 2. And so what's nice is from the vertex, or excuse me, from the focus, I could go, since the whole thing is 2, I could go 1 in this direction, 1 in this direction, and that would give me a pretty good idea of, see, if my focal width is 2, what this parabola is going to look like. Honestly, if I was doing this, I would also try to find what's the y-intercept. So when x is equal to 0, if I plug that in here, I'd get negative 2 squared and try to figure out what the value of y is, because then symmetry-wise I could put that on the other side and get a really accurate drawing of what this is. But this is all the information that I would ever ask you about a particular parabola. What's the vertex? Which direction does it open? What's its axis of symmetry? What's the focus? What's the directrix? And what's the focal width? Please remember, whenever you do these, the axis of symmetry and the directrix are always lines. So you need either x equals or y equals. The vertex and the focus are always points. So you need an x coordinate and a y coordinate. The direction of opening, well, that's either up, down, left, or right. And the focal width is always going to be a value. So we'll do another example of one that opens left or right in just a moment.